780. Draw the shear and moment diagram for the beam. So this is the beam. You can see here there is a fixed wall. So in reaction for A is AY, AX, and a moment at A. And you can see that there is a uniform distributed load here, 400 pound per feet, and it's 4 feet. There's another 2 feet to this pin A. So which means that this beam is connected with this beam at this pin, point B. Eventually, this pin is with a zero moment. So we'll talk about it once we come to the moment diagram. And there's this ruler, there's the reaction in the Y, there's 3 feet between B and C, C in the Y, and there's another moment at the ruler, 900 pound per feet. So how could we draw the shear moment diagram of this? The first things we have to take sections. Take this section out and take this section out. And you could analyze this beam like these two sections. You can see that we disconnected this section, take it to one side, make it like this. So this is B. We're going to have BX, and this, you could take it BY like this, or you could make it the other side. It's up to you, BX and BY. And remember here there is a reaction at the C. This is a ruler, so you're gonna make a reaction. You could call it CY, you could call it normal C. It's only one reaction, the Y. And there's a moment at ruler C, 900 pound per feet. So we take this to the side. Now, so what are you gonna do? The first things, the best is to find moment. Now, don't worry about this side. We took this side by itself because there is a hinge here, and this hinge will separate this side by itself. So the hinge, if you take moment at this point, which means BX and BY is not included into the equation, this will leave, if you take a nail here, this normal force, normal C or Y, CY, will rotate in the plus. So NC times 3. And of course, this is gonna go in the negative, okay? Minus 900. So NC times 3 minus 900 equal to 0. Now you could find the normal force at point C, 300 pound, 900 over 3. So we find the reaction in the ruler C. Now, you could find summation of moment at C and find this, but the best is to find summation of forces at the Y equal to 0. There is nothing in the Y except this one. So if this is 300, this is going to be 300 down. So BY going to be 300 pound. Or you could do summation of moment at C, and then you could do it BY going to give you in the plus times 3. And this is going to be in the negative moment, minus 900. You could do it either summation of force at the Y and find BY, or you could find summation of moment at C. Whatever way of doing it you could do. And there's nothing in the x-axis except this. So Bx equal to 0, because summation of force at x equal to 0 will make Bx equal to 0. So now we solve Bx 0, we find By 300 pound, and we find Nc 300 pound. Now, let's go to the other side. Okay, remember the other side is like this. So we take the other side. Now, this pin, and this will have one in the Y, one in the X, and there's another moment. It's a fixed. So we'll take it like this. And plus, remember that there was a 400 pound per feet. So 400 times 4, that is 4 times, it's 1,600 pound. And it is in the middle, because this is a rectangular, so rectangle gonna be in the middle of the 4. So 400 times 4, in the middle of the 4, 2 feet, 2 feet, and here there's AY, there's AX, and there's a moment at A. So here there's 3 reactions, one in the X, one in the Y, and another moment. Okay, so we took that side, and let's remember, here I assume BX going in the positive, so here I'm gonna assume it in the negative. Okay, you can see that these are opposite direction, the same value, but opposite direction. Same thing, BY, I assumed it down, and it was positive, so it's down. Here it has to be up. So it's going to be opposite direction in the same hinge or the same pin. So now we do it. What's the best? We remember bx is 0 and by, what was by before? 300. It's 300 that way. So we have this and we have this and we have this. Now the best thing is to find summation force at the y. Easy. Again, yeah, summation force at the y equal to 0. Remember, ay is up, 400 times 4 is down, minus 400 times 4, and plus by. And by was given 300. So this, you could completely find ay 1300, which means that ay is 1300. Now ax, remember 0? There's nothing in the x direction, so ax is 0. Summation force of x, ax is equal to 0. Now, we need to find the moment here. Okay? So you could find moment at any location. You could find moment at A or moment at B. They both will give you the same answer. Let's find moment at A. Remember, this will rotate in the negative, minus 400 times 4 times 2. This is not going to act because it's in the same line of action. This by going to make it in the plus, by times 6. by times 6. And plus, this is going to be in the plus, moment at A. It's going to go like this. Going to go in the plus. Moment A equal to 0. Now you could find the moment A, 1,400 pound-feet, and it's going that way. It's in the same direction. So now we found the moment, we find ay, we find ax, and we find both bx and by. So since we are done from this, now we will draw it. Remember, there is a reaction here, ay, so we should put it. Let me see if I can bring this. Okay, so there's a reaction here. So ay is what? What is ay? Ay is 1,300 pounds. So I'm gonna make ay 1,300 pounds. Of course, ax was 0. Ax was 0, and moment A is 1,400. 1,400. Let's say 1,400 what? Pound-feet. 1,400 pound-feet. So don't worry, at bx and by, we're gonna make them now connected again. We have this moment and we have this force, normal force Cy or NC. Cy or NC is 300 pound. So it is 300 pound. So no, there's no more reactions. Okay, now let's draw the shear moment diagram. Let's start with the shear. It's in pound, so I'm gonna make V pound, and I'm gonna make X in feet because it's in feet, and this is shear is in pound. So I'm gonna start like this. This is 1,300 pound up. So in the shear we only look at the y-axis. So 1,300 pound. So we're gonna go up 1,300 pound. We're gonna stop at this point because this is a reaction. And then you can see that this uniform force load will go down. So 400 times 4, that's minus 1,600. So 1,300 minus 1,600, that's gonna go to where? That's gonna go to minus 300. So you're gonna go like this all the way. It's linear. This is uniform loading, so you'll have a linear loading of shear because this is uniform. So the shear should be linear. So you're gonna go to minus 300, and here there is no loading whatsoever. So it's gonna go minus 300 all the way until it reaches here, and here there is 300 up, so you'll go up. Okay, so the way we do it now to find the moment is to do it from here. We should find, is there a moment here? 1,400. Look at this. This is, of course, this is like going plus, but we're gonna assume it's negative. So if it's going that way, it's gonna give you a negative moment. 1,400. Okay. Now, since we have zero shear, this is going to be a change of moment. So now, how could you find this moment here? For zero shear, you have a change of moment. You should find the area under this curve. So how could we find the area under the curve? We should find the bigger triangle, like 1300 plus 300. We should do it like this. 1300 and 300. We should do it like this. So we should do it like a big circle. 1600. And we have the whole, this is 1300, 300. The whole thing is 4 feet. And we should have the small triangle. The small triangle is what? 1300 and x, because we need to find this x. So if you divide x over 1300 equal 4 over 1600, x, this is 4, x will be equal to 3.25 feet. So 3.25 feet, which means that this is the x, 3.25 feet. And if the whole thing is 4 feet, so 4 minus 3.25, you'll get 0.75. So now, what is the area under this curve? The area under this curve is 1/2 1300 times 3.25. So 1/2 3.25 times 1300. It's the same thing, whether you multiply by that or that, it's the same thing. This would give you 2112.5. So what could you do? So this is minus 1400 plus 2000 plus this positive area of the shear. This would give you minus 1400 plus 2112.5. You will get 712.5. So this is linear. If it's linear, you're going to have a concave down until 712.5. So we came at this point. So now we're going to have a moment that is the area under this curve. So we know it's 1/2 times minus 300 times 0.75. So 1/2 times 0.75 times minus 300, that will give you minus 112.5. You add it up to the 712.5, the minus 112.5, so minus 112.5 plus 712.5, you will get 600. So this one from here to here, you will get concave down and 600. And now, here you have another area. But we should notice that here there was a pen. So in this pen, you would have for sure a zero moment. This is the axis. You have a zero moment at this point. So don't be confused. This hinge will give you zero moment. So we'll start from 600. We will have it from here, minus 300. From to here, that's 2. So minus 600. 600 minus 600, of course, obviously, gonna take it to 0. But you have to make sure that a hinge will give you a moment, zero moment at this. Minus 300 times 2, minus 300 times 3 from here to here, that is minus 900. So we're going to go from 0 to minus 900. And then we have, this is a plus 900. So minus 900 plus 900, it's going to go to 0. So this is the shear moment diagram of this example. So this example was solved. Now let's look for the alternative question.